All right, my friends, today is February the 25th. We are solving two-step inequalities. You will need a couple of things that are colorful to write with, probably a pencil because you should do pencils. You should do math with pencils, and you might want your trusty handy-dandy calculator friend. Let's get started. So first of all, we're going to start off with a refresher to solve inequalities. We follow the same steps as equations. The same steps, which means we need to use inverse operations. Inverse operations. This means that if I have addition or subtraction, I'm trying to make 0 on one side of my equation or inequality. So if I have x minus 2 equals 3, or even if this was x minus 2 is greater than or equal to 3. Since I have subtraction, I'm going to use the opposite, which is addition, to make 0 on one side so that I can solve it. So with addition and subtraction, we make 0. With multiplication or division, we make 1. For example, with this one, you might have x over 3 is greater than 2. Since there is division, the opposite of division, the inverse of division would be multiplying, which we're going to multiply by 3 on both sides. 3x over 3 gives me 1x is greater than or equal to 6, but as a cool mathematician, I don't write that 1. I just write x, because 1x is still the same as x. So don't forget about your inverse operations. Now that we're working with multiple steps, we need to remember our friend SADMAP. Remember that addition and subtraction will always have to happen before division and multiplication can happen when we're undoing the process of the order of operations. This will always happen unless you have something that's secretly or actually inside of parentheses. This would be something like things are grouped in the numerator of a problem, and then there's stuff in the denominator. You would have the top would be in parentheses, which means you would do your division first, then what's in the parentheses would be the addition and subtraction, typically. One more big reminder for inequalities is when you multiply or divide both sides by a negative value. Only happens when it's doing it on both sides. This is when it's your inverse operation. By a negative value, we flip the inequality. So if it was less than, but you're having to divide by a negative 2, we're going to take this. I typically like to just circle my inequality symbol, and when we're dividing both sides by that negative, we're going to be flipping it to the new sign, the opposite direction. I think that's all. So now we're going to solve and graph a few. And my last reminder, that was not all. Don't forget that when we have these symbols, when we're graphing, we're going to use an open circle because it's not equal. When we use less than or greater than symbols, we use an open circle on our graphing because it does not equal that number. It is not equal to that value, so we use an open circle at that number. If we have the less than or that's a greater than or equal to or a less than or equal to, we use a closed circle because that value could also be equal to. If your symbol is underlined, that means or equal to, and that's because the value in your in your inequality, like the 6 or this 5, that means that this 5 would be included as a possible solution. Now it's time to try some. I got 6 practice problems for us. So, new paper. All right, problem number 1. Actually, I'm going to pause and write them all out. So, hold on. Be right back. Boom. Here we go. So you have 6 problems. They're all 2-step equations. So the first thing we're going to do is we're going to move the addition and subtraction before we move the multiplication and division. You are welcome to pause the video, but I'm going to actually work through all of the problems live in the video in case you need that guidance. So with problem number 1, 3x plus 1. So I can't get rid of this 3 first. I have to get rid of this 1. So I'm going to subtract 1 on both sides. So 3, that made 0. So 3x is less than 9. And now I need to divide by 3 on both sides to eliminate that 3 and get the x by itself. So x is less than 3. When I take this to the graph, I'm going to put 3 numbers. It's just less than 3, so open circle, and it's going to the left. In problem number 2, I can't get rid of this divide by 5 first. I have to get rid of this subtract 6. So I'm going to add 6 to both sides. This eliminates because it makes 0. So x over 5 is less than or equal to 12. In this situation, I have a 5 being divided by x. So I'm going to have to undo this by making 1. So I'm going to multiply by 5 on both sides. This gets rid of my 5. It's a positive number, so I don't have to change my sign at all, my symbol at all. And 12 times 5 is 60. So 50, 60, 70. It says x is less than or equal to 60. So since it could be equal to 60, I'm going to color in that dot and go to the left because my sign points to the left. With problem number 3 here, I have a negative 2x plus 22 is less than 18. I can't get rid of this negative 2 yet because I have to get rid of this addition. The opposite of addition is going to be subtraction. This one's going to make 0, so it goes away. And 18 minus 22, I believe, is negative 4. 18 minus 22 is negative 4. And now I have negative 2x is less than negative 4. Be careful when you're subtracting these because this negative 22 is bigger and you're subtracting it from, so it is going to take you into the negative world. Ding, 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 ding. I have a negative number that I'm going to be dividing on both sides, which means I'm going to have to flip the symbol. When I divide by negative 2, it's going to change the sign of my number on the other side, which means I'm going to have to flip my symbol. This gives me x, and on this side, negative 4 divided by negative 2 is a positive 2. So my answer is x is greater than 2. We could plug that in and double check that it makes a true answer, but we're not going to worry about that right now. So x is greater than 2. So 0 to 4. I'm not including 2 as a solution because it does not say or equal to. And now my arrow, since I had to flip it, points to the right. Number 4. 7x plus 11 is greater than or equal to negative 31. Again, I have to start with my addition and subtraction. My inverse operation is to subtract. This goes away, and I still have 7x. And negative 31 minus 11. I have a negative number, and I'm going to go more negative. So basically, I'm just adding these two numbers and keeping it negative. So this would be 42. It doesn't matter that this number 42 is negative because I'm not going to divide by a negative on both sides. So in problem 3, my inverse operation was with a negative number, but in this one, I'm just dividing by that positive 7. So nothing is going to change about my symbol. So my symbol stays x, and negative 42 divided by 7 is negative 6. And just as you can see in this problem, when I divided the negative by the negative, this became positive. But over here, when I divided the negative by positive, it's still negative. So if the sign of your answer changes, that typically will be a reminder to you that you need to flip your symbol. Remember, when you're numbering your number line with negative numbers, it looks like you're counting backwards because negative numbers go in the reverse direction. The bigger they get, the smaller they are. It's not equal to, it's pointing to the right. Last two. Number 5. X divided by negative 7 plus 4 is greater than 5. Again, I need to wait on this guy, so I'm going to do this 4. I have to subtract 4 to both sides. So x over negative 7 is greater than, that's a positive 1. It's greater than 1. Because I'm going to have to multiply both sides by negative 7, I'm going to circle my symbol as a reminder. Times negative 7 times negative 7. That makes a 1, so x is less than 1 times negative 7 is just negative 7. And again, my 1 was positive, and when I multiplied it by a negative number, it changed into a negative number. So that reminded me to turn my sign around. Negative 7, negative 14. It is just less than, just a less than symbol, so open circle, and it's pointing to the left. All right, last problem. I tried to use X on all these, so I had to change the number. I think it was a K. So 4 minus 3x is less than or equal to negative 23. And things are a little bit flip-flopped here, but I have 4. It's a positive 4. So to get rid of it, I'm going to subtract 4. That makes 0, so negative 3x. And remember that that negative is with that 3, so we have to keep that negative there. And then less than or equal to, and then negative 23 minus 4. Same thing like this one. They're both negative, so I have negative 23. I'm going even more negative by adding those negative 4s. So this is going to be negative 27. Here I see that I have a negative 3x, and I'm going to need to divide it by on both sides. So I am going to circle my symbol to remind me to flip it. Dividing by negative 3 on both sides. X is greater than or equal to, and then negative 27 divided by a negative 3 is going to switch this to a positive 9. Boop, boop. Here's my 9. Let's do 18 and 0. This symbol says or equal to, so I'm going to color this guy in, and it's pointing to the right. Go ahead and check out the Canvas page to know what your homework is. Turn in your homework page, your classwork page, where you show all of your work. You don't necessarily have to have all your steps shown here if it's something you can do in your head, but I do want to see that you are graphing these problems and solving them and writing the right answer. Good luck. You're awesome, and I'll see you later.